Thank you. Can you hear me okay? Yeah. All right. Thank you very much for making the transition from the other room to this one, because it's just for this session. After that, you have to go back. So thanks for making the effort. So I'm going to talk about machine learning, obviously, and there's been more and more hype around machine learning in the last few years. Bill Gates said something like this, I think it was 3 years ago, 4 years ago maybe. Then a little bit more recently, there was this very famous venture capitalist in Silicon Valley who also predicted that there would be machine learning would have more and more impact. And who knows where this is from? Just raise your hand if this looks familiar. All right, very good. So for the other ones, this is a still from the series called Silicon Valley, which airs on HBO. So if you know Game of Thrones, well, it airs right after Game of Thrones. And it's about this team of very talented software engineers who build a revolutionary product. What I found was very interesting is that, so it's prime time. Like there's lots of people who watch this show, and in the latest season, in June, they've started speaking about machine learning, so machine learning on TV. I think that all of this sort of contributes to hyping machine learning. Again, another show of hands, who knows what this is? Yeah, everyone knows that. It's the Gartner hype cycle. And do you know where machine learning is on this curve? Yeah? It's kind of like, where's Waldo? There's another name for Waldo in French. It's Charlie. Maybe it's Carlos here, I don't know. Waldo is this guy, right? That's where machine learning is, like, at the very top. And what we're going to do right now is, so there's the alternative title to this talk. We're going to ski down this slope with the help of a tool called the machine learning canvas, sort of go past the current hype around machine learning. So, ooh. All right, my name is Louis Dorard. I'm the author of a book which is called Bootstrapping Machine Learning. It's sort of an effort to teach machine learning and help people get started with machine learning, which I wrote a couple of years ago. And what else? All right, if you're wondering about the t-shirt, this is not an eye test. This, you actually have to read it from top to bottom. And if you're wondering about PAPI, well, that sounds weird, especially in Spanish. PAPI stands for Predictive Application Programming Interfaces. So it's a conference, it's a series of events actually, and I'm the general chair of the PAPI's conferences. The last one was just a month ago in Boston, and the very first one actually was in Spain, in Barcelona. All right, so first things first, what is machine learning? I guess probably most of you are going to be familiar with machine learning. That's going to be useful. Who knows about machine learning already? Okay, almost everyone. So very quickly, probably the most famous example is spam detection, and then there's another one which speaks to everyone, which is predicting the prices of real estate, all right? And then you get a bunch of data, and essentially there's training data, and you sort of decide that you want to predict the prices, so you sort of fill in the missing values, right? There's examples of inputs and outputs, real estate properties and the prices, or emails and the actual label, spam or ham. And from that, you train a machine learning model. With that model, you're able to make predictions on new inputs. All right, and this is kind of similar to what we would do, at least for the real estate example, as humans. There's lots of use cases. I'm just highlighting a few of them. So in blue, you get the inputs. In orange, you get the outputs. Okay, so there's one that I quite like, and I'm going to show it in a couple of slides, which is this application that predicts the availability of bikes in the public city bike schemes. I've seen that there's one in Madrid as well. So the problem there is you've got the location of a bike station, and you get information about the context, like maybe the weather, or what day of the week it is, if it's the holidays or not. And with this, you want to predict the number of bikes at that station. Churn is probably one of the most popular examples in business where you have a customer in input and you want to predict whether or not they will still be a customer of yours in the next month. And then another problem which is quite interesting for this type of talk that I'm presenting, where I'm moving away from the actual learning, but I want to speak about everything that happens before and after the learning. There's the problem of anticipating demand. When you are able to predict the number of sales given a given product, for a given product and a given point of sale and a given date, then you can use this information to decide how many goods you want to ship to the different points of sale. So that's very interesting in the food industry to avoid wasting food. But if you don't ship enough because you want to avoid waste, then maybe you could have made more money by shipping more. So you want to predict accurately and then use this prediction to actually make a decision on how many goods should I ship to this location, that location, and there's a lot of constraints, logistics constraints that you have to deal with. So making the decision from the predictions, it can be kind of complicated. All right, and I've listed names of companies that implement these machine learning problems. If you don't have time to write them down, don't worry, because I'm going to tweet these slides, so you can just follow me and you'll get the links. All right, so this is Big Data Spain. So let's speak about data analysis. Sort of there's different sort of types of analyses, and you can sort of see it as phases if you want. Like you're starting from a descriptive phase where you want to say how things are currently. Maybe you want to pull up a dashboard or a report, and then you want to sort of guess what's going to happen in the future. So you want to predict the future. But it's all very nice. You get predictions of what's going to happen. It's still just a piece of information, right? You haven't acted on it. What becomes even more interesting is when you can do prescriptive analysis. So you can say, you should do this so that the future is going to be sort of optimized for you. And then, even better than prescriptive analysis is automated decisions. You don't even have to do a decision yourself. The machine takes care of it. And in the example that I gave with the anticipating demand and figuring out how much to ship to different locations, turns out that the machine alone is better than the human plus the machine. So it's better to trust just the AI. But that's a different topic. All right. The first two is kind of old school business intelligence kind of things. Interesting, but not the most exciting thing. I think that what's really exciting is when you get to turn these predictions into decisions, and you can actually impact the world. All right, so decisions from predictions. Going back to the example of predicting availability of bikes, this is the application I had in mind. It started in Bordeaux in France, which is where I'm from. And so what's interesting is that, this is the page for a bike station, and you get the information on how many bikes are going to be available throughout the day. So that's into the future. I think that's up to 6 hours into the future, something like that. And, it's nice. You can use that to sort of inform your choices of, where you should pick up the bike and where you should drop it off, to make sure that there's going to be a spot available. But still, it's not very practical. And what's interesting is that they've made a new version of this application that doesn't show you these predictions anymore, but it just helps you make the right decisions of where to pick up your bike and where to drop it off. So this is the new version of the application, so this is the sort of starting point. It tells me I can pick up the bike from the station which is closest to me. All right. And then it also shows me in the bottom that it shows me this prediction that I should drop it off at this particular bike station, because in about 45 minutes, which is the amount of time that the application estimates for my travel time, in about 45 minutes, I'm going to have 100% chances to be able to drop off my bike over there. And All right, actually there's a little bit of a distance between the actual destination and the bike station. Is because the station that was closest to my destination was probably predicted to be a little bit too full. So that's the sort of things that I care about as a user. Not so much the predictions, but I want something that helps me, make decisions. Very interesting move from these guys who developed this application. All right, let's go back to Churn because so this presentation has been labeled as a business one, so we have to talk about business examples. I'd say that the descriptive sort of descriptive analysis is going to be about showing your churn rate against time. So show how it changes throughout time. All right, so at least you know a little bit better what's going on. And then maybe you want to predict which of your customers are going to churn next month, and maybe you just want to predict next month's churn rate. But what really is going to impact your business is when you do something about these customers who you predict would churn. So the prescriptive analysis would be about suggesting for each customer what you should do about them. Right? And maybe you should propose them to switch their price plan, or send a promotional offer. There might be other things depending on your business. All right, let's start with churn prediction. What's the actual context here? Let's imagine that we're a software as a service company. We sell a monthly subscription to our SaaS product. And the question we're asking is this particular customer going to churn next month or not? The input is a customer. Up to you how you want to represent that customer, with which types of features, with which types of characterizations, like you could characterize who they are, but also their usage of the application. And the output is, it's simply either they churn or they don't. And then you'd collect data by just looking at your historical data, like up to 1 month ago, because if you look at your customers, the customers you had a month ago, today, you have the answer, you know whether or not they renewed their subscription. Right, so you can use all that historical data. But it's not so much prediction that you want to do, it's prevention. You want to prevent churn. So let's assume that we know who is going to churn. What do we do about them? As I said, we could reach out to them, but maybe we want to sort of prioritize a few of them, the most important ones. And when we do that, we have a few options, but maybe we just want to take no action. And there are cases where you can sort of identify people where that you don't need to do anything about. They will churn whatever you do. So it's nice if you can notice it. All right, so suggesting what to do about each customer, you want to actually come up with a list of prioritized actions. And to come up with these priorities, you're going to look at the customer representations in order to make predictions. But then you also want to take into account the uncertainty in your predictions, or the confidence in your predictions. That's the same thing. So that if you're sure that someone is going to churn, maybe you want to put that person at the top of your list. If you're not so sure, maybe you put them in the middle. Another thing which can be interesting and important in this example is considering how much money each customer brings. So maybe you want to sort of multiply this monthly revenue by the confidence of your prediction to sort of get a priority value. And then you sort your customers according to this priority value. Another thing you may want to take into account is that there might be constraints, such as you would not be able to send the same promotional offer twice in a row to the same person, obviously. So you have to take this into account. All right, let's do a little quiz. I haven't introduced what TP and FP is, so very quickly, P refers to positive, and positive is it's one of the two classes in our binary classification problem. Positive is when people churn. It's not really positive, but that's the convention. Positive is when people churn, so that's the hopefully less popular class, and negative is when they don't churn, right? And a true positive is a customer that you think is going to churn, and you write about that prediction. True refers to being right or not about your prediction. So false positive means that you think that someone is going to churn, but actually they won't. Right? So if you think that they're going to churn, you're going to take action, and this has a cost, right? Either it's time spent, or if sending the promotional offer is you win a free iPhone 7 Plus, that's a big cost. Right, but we're also hoping to gain something. I mean, if we're using machine learning, there has to be a gain somewhere, right? So what we gain is that, in comparison with doing nothing, if we do take action, then we're going to keep that customer. So we're going to get this revenue that we wouldn't have had if we would have done nothing. But there might be a success rate for that action. Maybe it's going to work sometimes, and other times it won't work. So imagine that we've got some super data scientists in the team, and that we make perfect predictions, right? Imagine that the average revenue per customer per month is 10 euros. I'm going to make it super simple, 10 euros per customer per month, and that the success rate of whatever action that we're taking is 20%. And let's also assume that the cost of an action is 2 euros, right? Every time that I take an action about someone that I think is going to churn, I pay 2 euros. What is the return on investment of this churn prevention campaign? Any guesses? All right, I see that some of you guys have the answer. Is that what you did? Yeah, 0. 0 return on investment, although we did have perfect predictions, right? Our model is perfect. So it can be quite interesting to start thinking about these things before you actually take time building a model, if it's not going to be useful. Which is why this particular tool can be useful. So again, this is a business session. I'm hoping that some of you guys are going to be familiar with the business model canvas. Who's familiar with this? Right. So it's just, a canvas is just like a document, sort of a visual chart to put ideas, or to, instead of having everything in one textual document, which is going to be very linear, you're going to put different ideas in space in a way that makes sense. So you're going to arrange things visually. And in this case, the idea is to describe this complex object that a business model is by listing the key components and arranging them in space in a way that makes sense. The machine learning canvas sort of takes this idea of also using a canvas, but it's not an adaptation of the business model canvas, right? It's just completely different. The purpose here is to describe also another complex object, which is a machine learning system. Again, not an adaptation of the business model canvas, and we want to describe the learning part of this system. All right, we're coming up with an intelligent system. How does it learn? So what data are we using to learn, and how are we using predictions powered by the models learned from data? And then, it can be interesting to sort of list out ideas of how we can make sure that it works. If you're familiar with this diagram, the CRISP diagram, this is where you'd use the machine learning canvas, so kind of early. And yeah, some people recommend to use it use it first. It's the entry point. That's the first thing you have to do when you're thinking about predictive application or a system that uses machine learning. So the general structure of the canvas is that there's this value proposition in the middle, which is going to tell you the what, the why, the who. So what you want to do, why you want to do it, and who's going to use that system or be impacted by this system. And once you've sort of set the stage, you want to speak about the how. So there's two parts. There's predictions, and then there's learning. Once you've identified how, you want to think about how well your system is performing. Okay, let's look a little bit more at this particular area of the canvas, the predict area. So it sort of starts with background information, more of a background view of what you're trying to do. So the machine learning task that you're considering. What is the input? What is the output that you're trying to predict? And what type of machine learning problem it is, like classification or regression. All right. So once you've done that, moving to the left, decisions. How are you using predictions to actually make decisions? That sort of gives background information. And once you've sort of thought about that, you can go more into the specifics of the constraints that you would have on making predictions. Like when do you have to make predictions? How long do you have to make these predictions? And also you can start thinking about how you would, now that you know how you use predictions, you can sort of think about how you would evaluate all of that system offline prior to deployment. Okay, the other part is about learning from data. So starting with listing out the different data sources that we have. So that's on the top left. Oops, sorry, I went a little bit too quickly. Top left, data sources. What's available? What are the raw data sources you can use? But since we're doing machine learning, we need to get inputs and outputs. So we need to collect training data that we can learn from. How do we do that? Once we're clear about that, again, going a little bit more into the specifics in the bottom. So thinking about the features, which are the characterizations of your inputs. So for instance, what is the age of your customer, or how many times have they used your application in the last month, these sorts of things. And then finally, you want to, once you know how you collect data, which features to use, you want to think about actually building models, right? You need these models to make predictions. So when are you going to need to build new models, and what data are you going to use for that? That's where you'll put that in the bottom right. Okay. The sort of upper left and right blocks are sort of related to domain integration, because it's about collecting data. So you collect data in the domain of application, and you make decisions in the domain of applications. All right. So in the two extremes, you've got domain integration. That's for the sort of background. And if you go into the specifics, sort of bottom half, you have the making predictions and building models blocks, which sort of give constraints or requirements for your predictive engine. So the engine that feeds from data to learn new models, and the engine that creates your predictions on new inputs. All right, so that was the sort of general structure of the canvas. What I'm going to do now is a little example. Oops. So I was speaking about an eye test in the beginning. Maybe I should have done that, because it's looks kind of tiny, but yeah, maybe I should. Actually, I'm going to try something different. I'm going to zoom in like this. That's better, right? Churn retention, right? So we're going to, customer retention, sorry. So I recommend to start with value propositions. So what are we trying to do? Well, essentially, let's say that we sell this software as a service, and the end user of what we're going to build is a customer relationship management team, right? And I'm going to make this example as simple as possible. So it might not be a real-world example, but at least you get a sense of what this canvas is about. So the idea is, for this team, we want to help them identify the important clients who are going to churn. We want them to be able to reduce the churn rate, and to, whatever retention efforts they're making, we want to improve the success rate of that, right? All right, that was value propositions. Now on to machine learning task. So we've seen that, the question is this customer going to churn or not? It's binary classification, and the input is a customer, the output is either churn or not. How do we use this information these prediction to actually come up with a good decision? Let's say, again, to make things very simple, that on the first day of every month, we're just going to look at all the customers and their predictions of churn or no churn, and we filter out all the no churn, and for the other ones, we sort them in the order that I presented earlier on, right? And we're going to start soliciting these customers, right, from the most important ones to the least important ones, and maybe we'll stop somewhere in the middle, right? But at least, that's the first version. Contact them in this order. What else? Data sources, that's important. What is available to, what data can we leverage for this? So obviously, all the analytics data, all the data about the customers. So, if we're using a CRM tool, there's going to be interesting data in there. Maybe we want to consider all the emails that we've sent to customers. And yeah, just a few ideas. All right, how do we collect data? That's something that I mentioned earlier on. We can sort of see, we look at last month's customers, and today we are able to say whether they churned or not by just looking, at the payments database. If there was a payment, then they're still a customer. Otherwise, they're not. And what you have to think about is that the inputs, the customers that you're considering in your data that you're collecting for learning, it's the customers that you had 1 month ago, but represented as they were a month ago. So it's kind of like a snapshot of how they were a month ago, only considering the information that was available at that time, right? Okay, what next? Features, I spoke a little bit about features. So how are you going to represent customers? Basic information like age, city, that sort of things. And also, maybe you want to take into account everything that happened between T-1 and T-1 month and T. So how they use the product, did they interact with customer support, any other contextual information that would be available. Okay. What should we do next? Let's look at making predictions. All right, so this is fairly simple. Every month so I said we featureize, which means we create the feature representation for customers. And this has to be updated because things change, right? And we make predictions for all of them. And we could say that since we take these decisions on the first day of every month, maybe just before that, overnight we can do all the predictions, and at the same time we're going to build the models. Overnight we build models and we use them to make predictions for all our customers. So when do we create these models with training data? So what we could do is every month we create, before making these predictions, we create a new model from the customers that we had in the previous month. All right, so we keep sort of adjusting to potential changes in the behavior of customers. We use a different model every month. And you could argue that this would not be the right thing to do in your company, or this is just, again, a very simple example. I'm trying to make things as simple as possible. Finally, you want to sort of evaluate that what you're doing is working. So the simplest thing to do is to look at churn rates. And also maybe you want to sort of monitor how successful your retention efforts are. So looking at how many people don't churn among all the people that you contact, and divide that by how many people you reached out to, how many solicitations, or however you want to say it. Okay, again, just ideas. Let me switch back to... That's just a suggested order. You can fill it in any order that you want, but yeah. All right, one box that I did not fill in is the offline evaluation. I'm going to explain why. First of all, I want to make an important point, which is that sometimes we're going to predict that a customer would churn. We're going to take action, and it's going to be successful. So the customer, in the end, is not going to churn, which is great, but because the prevention or retention efforts worked, but your data is going to be inconsistent because you predicted that this customer would churn, and actually you would have been right, except that you did something, and in the end they don't churn. So you're sort of messing the data here. So maybe, one way around this could be to sort of store which action you took for each customer, but that's not completely clear. Anyways, if you do take actions, you also have to record that in your data, right? That's also very important. But, have to think about how to use that later. Who's seen this movie? All right, pretty much everyone again. You guys are a great crowd. All right, so this movie this is Alan Turing, not Doctor Strange. I saw his face also at the entrance of the Kinépolis, and yeah, he was playing Doctor Strange. But this is Alan Turing with this machine that cracked the code of Enigma during the Second World War. So the film is sort of about his story, and in the background they're trying to crack this code, or in the foreground, however you interpret the movie. And the thing is that in the end they succeed, and they're like, oh great, we can crack all the code, we can decipher all the messages, and they're like, oh no, but actually we can't. Because if we do use this great machine, then the enemy is going to figure it out. They're going to realize that we're able to predict everything that they're going to do, so we must have cracked their code. So they're going to come up with another device, and then we're going to spend ages trying to crack the new code, right? So they realize that they've built something very complicated and they can't use it. Well, they can use it, but just a few particular times. Not all the time, but just for a few key things. And sometimes they know that some people are going to be attacked, and in the end they do nothing because, again, it's a very difficult choice to make. But it's kind of like something similar is going to happen with machine learning. You're going to build something very complicated, it's going to take a lot of effort, and then at some point you have to explain to your manager or the decision maker that you're not going to use what you built. Good luck with that. The reason is, all right, so if we, as I said, the data would be inconsistent. So the way to the simple workaround is to sometimes use the model and other times not to use it. So I'm going to zoom in on that again because you can't really see it. But I've chosen to do something a little bit different here. So I'm randomly filtering out a part of the data set, so half of my customers. I'll call that the holdout set, but you can call it however you want. And I do the same thing, but only on the 50%, the other 50%, right? So if I do that, then what I can do when I'm building my models is, instead of using all the customers, I can just use the holdout set, which is clean, sort of, because I did not use these guys. I did not mess up with these guys. I just let them do whatever they wanted, and I'm learning from that. All right. What's next? And then what's interesting when you consider this sort of holdout set is that you can use it for various evaluations. You can actually compare what you predicted versus what happened for these guys, and you can monitor that. What else can you do? You can, you can sort of, what did I write here? So I'm gonna write a blog post. So if this is a little bit confusing, or if you don't have time to read and understand everything, even me, when I'm rereading it, I'm having trouble to sort of remember what my point was. But when you can compare what happened between the set of customers that you acted on and the other ones, and you can sort of compare the churn rate, for instance. All right. So what you're hoping is that there's going to be less churn in the customers that you acted on rather than on the holdout sets. Right. So there's ways to use this holdout set for live evaluation. All right, this is what it looks after all of that, and still this offline evaluation part is missing. All right, so this is what this is my idea for an offline evaluation. Maybe you'll have another one, but what I like to do is to sort of come up with simulations where I try to replicate the same thing as was listed here in the making decisions from predictions, but on historical data. And yeah, I want to do that. I want to do this offline evaluation before I start, sending promotional offers or before I start acting on my predictions. And I want to evaluate and see how well it's going to do. And I want to make sure that, I'm going to have a positive ROI. So, okay, this is the interesting part. Maybe you have like predefined customer profiles. You want to make sure that the model behaves well on these predefined profiles, on these test cases. But that's the particularly interesting thing, I think. You want to simulate decisions taken on last month's customers using the model learnt at that point, which is on the customer like 1 month before, so like 2 months ago. And you want to compute your return on investment when you're making, when you're soliciting like a different number of customers. I said that we just list them out in a certain order, and we just reach out to them. But maybe there's a point where you should stop, because there's a point in that list where that corresponds to predictions that are too uncertain, all right, where the churn probability is too low. And for these guys, it's not useful to reach out to them. So you want to sort of figure out what is the right threshold. So you can simulate that. You can simulate different thresholds, different numbers of customers to reach out to. And you can also, so you're going to have to make a hypothesis on the retention rate, but you could just say that the retention success rate is going to be the same as your churn probability. Just an assumption, but yeah, you have to have something there to run the simulation. And in the end, you look at your return on investment has to be positive, and you're trying to find like the right threshold. So that threshold is sort of a parameter to this. You tune that parameter here by doing evaluations, simulations. That's what I wrote here: solicit as many customers as suggested by simulation. Right, or by offline evaluation. How am I doing with time? Anyone keeping track of time? Yeah. I think I'm almost done. All right, so why would you want to fill that in, that machine learning canvas? I think it's a great tool to make sure that everyone works on the same thing, so you align everyone's activities. It can be challenging when you have people of different backgrounds working together. So yeah, they can all use the same sort of reference documents, which is what people do also with the business model canvas. Everyone uses the same thing as a reference. If you do that, you make sure that everyone is working on the right problem, and sometimes that's not the case. You have people who know very well how to make accurate predictive models, and other people who know how to serve the organization's objectives best, and they're not the same people, so it's difficult to bridge that gap. That's a tool that can be helpful for that. And then also, once you've identified all the constraints of your machine learning system, then you'll be able to make a much better choice in terms of the technology you want to use for the implementation. It can also help you to guide your project, your machine learning project. If you want to read more, there's this website, machinelearningcanvas.com. And yeah, you might think that machine learning is about training model and making predictions. It is, but there's a lot more to machine learning. So yeah, that's what the canvas is about. Everything that happens before and after the learning. And there was this great article on the O'Reilly website. Again, the link is here, so you'll have to find it from the slides. But yeah, predictive modeling, that's super important, but it becomes, it disappears into the plumbing, as Jeremy Howard said. If you want to, again, read more, I just published this article, part 1, which is about like the first sort of overview of the canvas. So yeah, it's on my Twitter. You can either recommend it, tweet it, retweet it if you enjoyed the talk. And if you didn't have time to take notes, then here you go. Before I wrap up, I've got 2 plugs. The first one is that Papis runs these conferences, but also has this machine learning fellows program where we teach machine learning to people who want to use it in the real world. So yeah, the idea is that people learn, but also they get to apply what they learn to real projects. and they learn from mentors who've been there and who've actually implemented machine learning in production. So there's this, and then the other part is like companies who want to outsource part of what they do, or they don't have time to realize to implement some ideas. They can come to us and sponsor projects. Right, so there's this, and the other thing is that we're hiring. That's the usual slide to wrap things up. And yeah, you can follow us on Twitter. But yeah, we're hiring for running the conferences, but also mentors to help for these machine learning programs. And that's it. Thank you. Do we have time for questions? I guess so. Any questions? Yep. Go ahead. I don't know if there's a microphone for you, but. The right algorithm. I think that that's not so much what I think is important in the beginning. So the question was, how do you choose the right algorithm to start with? I think that you'd be able to make a much better choice of algorithm once you've filled out this canvas, because what it allows you to do is to list out all the constraints. So constraints on maybe the latency or the throughput of your predictions and of the learning, and maybe constraints in terms of do you need your model to be interpretable or not? And based on these constraints, you would choose certain types of algorithms and others not. So I think that the first thing to do is really to fill in this canvas, or maybe you don't want to use the canvas, but you want to think about the same questions that are listed out in these different blocks. So you want to think about all the aspects of your machine learning system, and then you'll be able to make a much better choice of algorithm. Any other questions? Yes.
The simulation part, it's the one that worries me more.
Okay.
So how do you do that? How do you make sure that the project is worth it?
Yeah.
Actually, you just make assumptions and you live with that. So just
you always have to make assumptions at some point, because you're making simulations. It can be tricky. That's I agree that it's not the simplest part of the canvas to fill in. But I think that the idea is to think about a way to evaluate what you do, which is not just simple metrics, generic metrics like R squared if you're doing regression, or you want to sort of evaluate based on the data that's available. You want to see what would have happened if, okay, I'm making these predictions and then I'm using them in a certain way. In that case, what you would be doing is, like I said, simulate decisions taken on last month's customers, and then you can sort of evaluate. You know today if they churned or not, so you can sort of see if your decision to reach out to this customer was good or not, based on the fact that later you know if they churn or not. So yeah, it can be kind of complicated, but the idea is to think about domain side evaluation measures and try to implement this this process that you listed out in the using predictions to make decisions. I guess it's you always have to make assumptions, but at least once you do that, once you do simulations, the good thing is that you can present it to a decision maker and say, under this assumption, this is the performance measure, under this other assumption, this is what we get. And yeah, there's always assumptions, but at least it makes it easier than just saying, okay, the recall and the precisions are this and that. It's easier for a decision maker to understand the potential of your machine learning system. But yeah, we can speak more about this particular example if you want afterwards, or another example as well. And I've got copies of the machine learning canvas, printed copies if you want to get started now.